What's up guys, this is Coding Cleverly. Today's video is going to be the continuation of the two-part series of linked lists. So the previous video had the first part of linked list where we discussed the logic behind the linked list and how we created it using classes, and also we implemented it using the function of append and also display, and we worked our way in the main logic and showed how it works. So if you didn't watch that video, I encourage you to click on the card on the top right corner and go watch that video before heading out to this video, because this video is going to be an additional to the linked list, and what we're going to do is basically add additional functionalities to our already built linked list. Alrighty, so now let's take a look at our first member function that we're going to be designing today, and that's called the count function. And the count function's purpose is to display the number of nodes present in our already constructed linked list. So how do we get this done? So first let's take a look at a graphical representation of a linked list. So basically we have a head pointer like we discussed before, and what it has is basically it points to the first node in the linked list, and also you know that the data that it points to is also in there. So this is basically, let's say something as 2, and then this contains a data and then calls a pointer that points to the second node, and it would point to something like 3. Then this is the data value, and then there's going to be something after that. This is going to be a pointer and it's going to point to something else, let's say 4. And it doesn't necessarily have to be like this in a pattern, but it could be randomly scattered values, you already know. And then after that, it's also scattered out in the memory. Remember, this is going to be in some portion in the memory, some hexadecimal value, some hexadecimal value. And then over here, we're going to have something over here as something like say. And then after that, we have something that points to the null. So to cut it out, we have head that points to the first node, and it has the value which is the first node, and then that points to the second node, and this points to the third node, this points to the fourth node, and then this fourth node points to the null, indicating that the linked list has ended. So this is a singly linked list basic concept. Okay, now what we want to do is basically we want to create a count function, and what we could do is basically have a temporary variable that could point to the head, and we already know the head is pointing to the first node, so that we got the first one, and we could implement like count 1, and then after like we could traverse it, and then we could increment the count to 2, and then after that we could traverse it, increment to count 3, and after that traverse it, increment to count to 4, all the way until we have a temporary that not equals to null. If it equals to null, we could just get out of the value. So not equals to, you already know, this is the exclamation equal sign, which is not equals to null. Sorry about that. So if it's not equal to null, just get out of the loop and give me the count. So that's the purpose of the count function that we're trying to implement. So let's go and let's see how we can do this. So now let's go back to our IDE. So I'm going to go, and now let's create our count function. So the basic concept here is that we have a return type of count, a return type of int, sorry. And now what we're going to do is basically create a list node, pointer to list node, and it's going to be called temporary, and it's going to start by having the same address as the head. And what's going to happen is that it's going to be pointing to the head. Sorry about that. And what we're going to do is basically while temporary not equal to null, and what you're going to do is basically, the thing is that you're going to have a count that is going to be incremented 1 plus 1, but before that we need to define it here. So let me just declare a variable that is count, and it's equal to 0. And what we're going to do here is we're going to traverse. So we're going to say temporary, and we're going to traverse to the next pointer right here. So next, there you go. And now after that, we're just going to return the count. So we're going to say return the count, and yeah, so basically that's it with our function. Okay, so now let's see how this could work. So over here, after the display function, what I could do is I could invoke the count function over here. So I could say console output, I would say something like count, and then we could say c dot count, C-O-U-N-T, and put that function inside end line, and I'll control alt and N to run the code. And suppose, yes, so we have 3 nodes, 1, 2, and 3. The count is 3. That's perfect. We worked our way and designed a proper implementation to this. Great. So now what we could do is now go ahead and see the next function in our list. So the next function that we want to create is something that could erase a node. Now, how do we basically have the ability to erase something. We want to erase some kind of node. So basically, if I go back to my implementation here, I want to erase something. Like for instance, I have this 4 and I don't like it. I want to erase it. So how do I want to remove this. I want to deallocate it from my memory, and I just want this 3 to go over here. So I want this to just point to this instead of pointing it to the 4th one. How can we do this? Well, we need another, I would say, a pointer. When you could create like a junk pointer that could point to this portion in the memory, and then after that we could delete the portion and then reassign it. So the other case we need is that we create a temporary that could traverse to that location, but we need to go one step before, because we want to delete this specific thing, right? If we just go over here, it could cause some problems with referencing. So we go one step before, and then after that we say something like, if the next of it is that current value, right? The next of it is that value, then after that do some proper implementation. So don't worry, just go in the code and you'll understand. So void, we say erase. So void erase, and now what we could do is inside of it we just put a value d that we want to erase. So remember I said that we need a list node, so we'd say list node temporary, and we start from the always head. Okay, so the first condition here is that we're gonna have this while loop because we want to traverse. So we say temporary not equal to null, which is basic, and then we need another condition, and that condition is temporary's next value, right? And that should not equal to null as well. And then the last condition, what we need to do is basically temporary's next value, what I was talking about, next data value should not equal to that value that's in the parameter, right? And if it is, then you could have to do the implementation, the junk pointer thing, what I was talking about. So just wait. So after that, we just, sorry about the data, it just should be next over here. And right here, we should have a list node. And before that, let's have a condition here. So I'm specifying a condition right in here. So let me just delete this. And I'm gonna specify that if the temporary not equal to null, because want to make sure that it's not null. If it's null, remember you could just delete any portion of your computer memory, and we don't want to do that. That's dangerous. So having something secure like that is really important. So list node temporary junk, and then we say junk is equal to temporary, and then we have the next pointer to it. So we know that for a fact that junk is going to be pointing to the next one, and I could tell you like back again over here that we had to point to the next. So this is junk, right? We're over here, this is our temporary, and we want to point to this as the junk. We want to create this as because this is our purpose. Our purpose is to delete this 4. How do we do this? We say temporary is next is this thing, so we want that as specified junk. So that's what we said. Go back over here in the code, and we said that that's junk, so that's junk. And then we could say is that the temporaries next now is going to equal to temporaries next, and then we have next. So temporaries now is going to move forward, and it's not going to go here, but now it's going to go next and then next. So what that means is instead of going over here, which is temporary, it's going to go over here, and this is going to be deallocated from the memory. So well, we're going to go back in here and now simply use the delete keyword and just delete the junk that we don't need. Okay, so that's basically it with this erase function. Now what we do is basically test it out over here. So we could just say c dot erase, and let's see if I could erase something. Let's say I want to erase 23. Now Control Alt and N to check it out, and you have an issue over here. So line number 23, I have a capital C. The line number 93, sorry. So let me just I want to kill this. Why am I plussing this? Let me just delete these. Yeah, so let me just kill this terminal from here. Okay, what I want is basically the C was capital in line number 93. So I'm just looking at it, see where it is. Oh shoot, this is capital. Lowercase, sorry about that. Control Alt and N. And let's see, it's running. It's running. There you go, 1949 and count 2. Okay, we deleted one element. Now let's go back and delete this again, kill terminal. And now we want to delete something like 49. Okay, let's say 49 over here, and let's delete it. Okay, 1923, okay, count is 2, awesome. So we deleted 49. But the question is, if I could delete the first one, Now if I do 19 and I save it, Control Alt and N, there's a condition here that it's not working, it stopped working. Why is this so? So the case here is that I didn't specify my boundary conditions. My boundary condition is that I didn't implement the case that if the head value had to be deleted. So over here where my erase function is starting, so I would just say like if, now I necessarily don't have to delete the head, the first node. So I could just say if head data, and then we say if it equals to the D, right? We could just basically say return. And if you want it deleted, you could just specify that junk, same thing. So what do you mean by that? I could say list node, and I could say pointer to list node junk, and I could just specify it with head, and I could say heads. So heads next is basically going to be specified as head next, and what we could say is basically delete the junk from here. Now, and the last thing what we have to do is return. The major concern here that I forgot. It should work now. So Control Alt and N. And there you go. Awesome. It worked. Amazing. So we got this working as well, which is great. Now that we have our erase function defined and implemented, let's create another function. And this function is going to be inserting something before the current. So I would say let's go back over here, and I just wanted to address one other thing. Let's say before even doing that function, let me create a getter thing. So I would just say void. I want to show you what's inside of the head. So getter, I would say guest first. First I want to get the first node. All right, and I just want to see the get first node, and I don't want to contain anything. And what I want to do is basically have something specified, no input parameters, and what I want to do is specify something. So I want to say that the heads data, and I just want to see what it is. All right, now if I specify that in here right after the account, let's just say over here c dot, let's just have a count over here, console output and line, and right here I would just specify first node, get first node, and what I want to do is just call it, and I want to see what's the value, because the first node's value, remember I said to you, is the heads node. So whatever the head value is, it's basically 19. It's going to give me 19. So Control Alt and N, and wait a minute, why did it be 23? Because I deleted it from here, so I erased it. Now let me remove that, and now let me try it again, and it's supposed to give me 19. Okay, awesome. 19 is our first value. So okay, that makes sense. How about now if we do something else? So let me do something right here. So if I want first node and I want to see the next value after that, so you can say this is basically first node, and then we have console output, and we say head, and I could just implement through here data, and then we say, or we could say next, and then we say data, and then we say we want that one. So this is going to give me a second node value, and then we can have console output, and we can say head, and we say next, and then we say next, and then we have data, and then we have end line, and we say that as a third node, if that's even possible. So I may be limited to some nodes, so let me just append one more, c.append, and let me just create a node that has some random value. Yeah, so some random value here, Control Alt and N, and let's see. Okay, there you go, 19, 23, and 49. What happened here is that we got the first, second, and third, and that's what I specified. I wanted 3 node values. So you could get my point here that this contains the first node, this contains the second node, and this contains the third node. Okay, so that was out of the way. And now let's create our member function, which I wanted, which is basically going to insert something before. It's going to be called insert, and we're going to call it before. And it's basically going to get a data. It's going to get an element that you want to insert before. So let's see what we want to be, insert before. Let's say what we want here is basically, let's say, okay, so if head is equal to some basic implementation that I'm going to be doing and then explaining afterwards. So just type along with me. Return, and then we have over here if head data. So over here, because we want to insert before, and we have it E, so we could just basically have some proper implementation here, which is list node, pointer to list node, temporary, and it's equal to, which is new list node, and we put the D inside of it. And then what we could do afterwards is basically temporary's next value is going to basically include head, and then we could say head is equal to temporary, and then we could just simply return the value from here. And the last thing what we could go through is the list node, which is pointer temporary, and we could just say that as head, and we could just say while the condition that temporary not equal to null, and then we have a temporary not equal, temporary is next, so basically next data not equal to E. So this is not equal to null, and temporary is next not equal to E. We could say just keep on traversing. So we just want to traverse, and right after that we could just basically do if that temporary not equal to null, and now they could implement the junk thing. So we could just say list node, but in this case let me just change it up and say nn, and want to have new list node, and want to have something inside of it, let's say D. And what we could do is basically nn, and we could say the next to that is equal to temporary, and we say next, and inside of this we could just say temporary next is equal to nn. Okay, so I believe that this was it with this function. I know this was pretty long, but don't worry, I'll explain everything. So let me just save this and let's see how it would work. Over here we have it implemented right in this case. So let me just delete this. I don't need that. I don't need this end line as well. Let's say we want to display it, but we want to display it before, like we actually will want to do some implementation, and afterwards we want to display something. So let's say get first node. So that was my other function. What I want is basically insert before. So let me just say c dot insert before, and what it gets is basically a data and an entry point. So let's say we want to insert something like 3333. Okay, we want a 3333 before the first node, which is 19. How do I do this? Basically I put the value in here, and I'm gonna get a 333, so I could just say show you over here that I'm just gonna get some kind of new node that is 3333, and what it's gonna be, it basically head is gonna be pointing to this, and instead of that it's just gonna break this reference, and it's just gonna start from this. This is how it's gonna be going. So how do I do this is basically I specified that I want to start from 2, and I said before 2. So I know that it wasn't 2 in this particular case. In my program, it's actually 19. So let's run this code, Control Alt and N. And you can see over here we have 3333 before 19, and that worked pretty cool. They're pretty simply and easily. Okay, so what about having it changed inside of it? Like if I want it inside, let's say 49. So within 49, I'm gonna get it before 49. So just keep a watch out over here, Control Alt and N. I'm gonna get it before 49. So there you go, 49, and we have 3333 before, and the count is 5 because there's 5 nodes. Amazing, we're doing crazy stuff over here. All right, so the explanation to this is pretty simple and pretty straight to the point. What we have is basically a data, and we have an element that we want to specify before. So we'd say head is equal to null. We basically simply, it's empty. Head is null, so that means it's an empty linked list. Just return simply. If head data, the first node, is equal to the entry point, then how are we going to basically do it? That's what basically we did in the beginning. So we would say is basically we have a temporary is equal to new list node D, and we specify that next to the head. All right, and we say head is equal to temp, just like what we did over here. We specified that head to this new thing, and then we specified that broke the old reference, and now it changed. So that's what happened over here and returned. And now we have list node. If that wasn't the case, so if it was somewhere else, so we just have a traversal over here and not equal to null, and then we say is next, because we want it before. Remember I said like we need it before. So if you want to do it, if you want like something before, you have to look at the data value, so you know that this is the data value and you want that before, so you want something like next something. So that's why I placed next over here, next data not equal to E, traversal, and then I basically implemented an NN, new list node D, had the values that we specified inside of here, and then we said the next to that is basically the next to the temporary, and the next to that will be the end. Simply what we just did is similar to this, what we did. Okay, so basically that was it with this video. I hope you like this. Stay tuned for more videos just like this. If you have any questions related to linked list, this implementation, or whatever, please let me know in the comment sections. I will be reading your comments and trying to respond as soon as possible. Don't forget to subscribe to the channel and keep supporting Coding Cleverly. Until then, peace out.